Give me a second. Let me share it. Guys, I will share the link with you so you can also put it on your. Okay. YouTube. Facebook, I'll have to go with Peter. He's busy writing, so let me give him some time to do it. Okay. Oh, so you are connected. Good. Let me put it on the status. Okay. Updated my. Oh, okay. Joel has updated his. Hi, my people. It's afternoon. Yeah, yourself. Ah, I think it's better with the light on. Ah, this one. Oh, yeah, it's blinking. You put it off. Yeah. Ah, it's maybe it's also dark. You put it on. Yeah.
Unless you maintain it. Sorry.
It's okay, unless it's blinding someone's eyes. The problem with webcam is the pictures come in the opposite direction. No, but if you're using a phone, you can just switch cameras, right? But this one is facing. Yeah. We can use the phone, that's fine. Hey, we have three people. Yes. Oh, it's the three of you.
But you can show the video without the person.
Without the. Oh, no, it's okay. Ah, okay, don't mind me. I can, it's showing properly here. On your phones, right? It shows here. And I was just. What are those online? I can't see you. Okay. Maybe I'll just start whilst you guys wait. You guys wait. So I'll just go through this question. Then Joel will take over for me. Then I'll go with Peter to the other room to do the Facebook Live. Then you can do Instagram Live. Because we want one person per page. Yeah, you just came, so you are now. So go through. Remember, I shared the files with you last week. So I just picked the BECE. Yeah, this one was interesting. Okay, it looked very practical. That's why I picked it. Okay. Okay, we're about to start. Hello to our viewers. We're about to start our lesson for today. So before our tutor Joel comes, I'm going to go through these two questions. Let's say the questions of the day. So we are taking it from BECE 2015, the theory part, question 1A and question 1C. Okay. So we will discuss it and see how can you approach this when you see it in your exams. Okay. So let's see, what does the first question say? It says that find the difference between the products. Okay, so I'm going to underline the keywords here. I see difference here. Okay, I'm going to circle it. So we have a difference between the products. So we have a keyword product here of the numbers 2.5 and 7.5 and the sum of 2.75 and 9.55. Okay, so let's try to decode this before we solve this. Okay, so when you think of difference, so our solution, when you think of difference, it means subtraction. Okay, the same as subtraction. and we use the symbol this. Okay. Then product is just multiplication. Sum means addition. And yes, that's all. Okay. So now let's see, how do you solve this? So you have to find the difference between the product of this. So you want to find a difference. So you want to subtract two things. So you want one on the left and the other on the right. So the number on your left will be the product of 2.5 and 7.5. So we said product means multiplication. So the product of 2.5 and 7.5. Okay. Then on the other side, you want to find the sum of 2.75 and 9.55. Okay. So how do you solve this? We have to simplify each of the brackets first. So in this bracket, we are multiplying. Okay. So we want to see what will be the fastest way to multiply it. Okay. So personally, I think of this. I want to put this in standard form first before I multiply. So 2.5 is the same as 25 times 10 raised to the power minus 1. And 7.5 is also the same as 75 times 10 raised to the power minus 1. So simplifying this, so I'm going to multiply my 25 and my 75. Then in indices, so the bases are the same. You have the base 10, but the powers are -1 and -1. So what do? You add the powers minus 1, minus 1. Okay. So what's 25 times 75? Okay. I'm going to try to multiply on this side. So 25 times 75. 5 times 5 is 25. 5. Remainder 2. 5 times 2 is 10 plus 2 is 12. 7 times 5 is 35. 5 remainder 3. 7 times 2 is 14. 14 plus 3 is 17. So when I add this, I get this. Okay, I get 1875. So this whole thing here is 1875. But minus 1 is minus 2. So this product here, we just computed to be 1875, but with the power minus 2 means that you shift your decimal point 2 times to your left. Okay. So I'm going to write this on this side. Okay, yeah. So this is 18.75. Then minus. So I apply the same thing here. I want to multiply 2.75 and this is addition. Okay, so that will be a little easier. Okay, so because this is in the theory part, you have to show your working. Okay. I'm not showing it nicely. I have to do it properly, but I'm not doing it properly. But yeah, you see, I move from one step. This is equal to this, equal to that. Okay. So now let's add 2.75 to 9.55. So 5 plus 5 is 10, 0 remainder 1, 7 plus 5 is 12, plus 1, 13, remainder 1, 11, 12. So that is 12.30. Then now I can do my subtraction. So we can also do it this way. I think this is easier seen in that way. Okay. So 5 minus 0 is 5. 7 minus 3 is 4. 8 minus 2 is 6. And 1 minus 1 is 0. So we arrive at the answer 6.25. Okay. So the key lesson to take from this is that when you're given a story problem, you have to try to decode the keywords in there. Okay. So from our question, the keywords were difference, which we said means subtraction, product, which means multiplication, and sum, which means addition. Okay, so you've been able to identify your key operations: multiplication, subtraction, and addition. But how do you arrange them? They say I find the difference between. So you have difference between two things, right? So you put your subtraction sign. What is on your left will be what is here, and what is on your right with this. So what's on your left was the product of these two, and what was on your right was the sum of these two. Okay, and try to show working because this is the theory part. Okay, great. So later on you can send your questions. For now, you'll not be able to interact with that, but you can send us questions for us to review later. Okay, great. So that's us for the first question. The second one I chose because I felt it was very practical. So very often people say mathematics is too abstract and we don't really use it. We just do all that crazy stuff and worry you with it. But okay, it's very useful. Okay, so let's see. Our question says that a container is 24 meters long, 9 meters wide, and 8 meters high. Okay, so I'm going to try my drawing skills here. Okay, not bad. So here's my container. So it is 24 meters long, so 24 meters. 9 meters wide, 9 meters, and 8 meters high. 8 meters. Okay. Now, how many books can you hold in it if each book is? So we are going to draw a book. So this is our book. Maybe someone's book. So here's our book with dimensions: 20 centimeters, 16 centimeters, and 6 centimeters. Okay, so you can think of it as you having this box. Okay, this box is our container, and we want to see how many chalks, okay, in this case books, can we arrange in this to get the maximum you can fit in. Okay. So what comes in mind? So I mean, when I look at this, the first thing I want to do is to convert these units to the same units. Okay, because here we see meters, here we see centimeters. Okay, and when you think of things that you can fit, hold, you think of it as volume. Okay, how much can you fill it with? So volume of something is how much of the material you can put in it. Okay, so you want to see if you have a book of a certain volume, how many of these books can make the volume of this. Okay, so the key concept here is volume. Okay. Volume. So what is volume? So you find volumes if you have a three-dimensional object and you want to find how much of a substance you can put in. Okay, so these are 3 dimensions. What is volume? Volume of this cuboid. Yeah, this cube is length times breadth times height. Okay, and the book too is the same. So we want to use volumes, but we also want to make sure that our units are the same. Okay, so I would want to convert my meters to centimeters. Okay, so if I convert my units, we know that 100 centimeters makes 1 meter. Okay, so how many centimeters will be 24 meters? Will just be 24 times 100, which should be 2,100 centimeters. Okay. Similarly, 9 meters is just 9 times 100 centimeters, so that will be 900 centimeters. And 8 meters will be 800 centimeters. Okay, so we want to see if we find the volume of our book, how many of these will fit the volume of our container. Okay, so it's all about volumes. But let's first start with finding the volume of the book. So volume of book. What did we say the formula for the volume is? It is the length times the breadth times the height. Okay, so that would be 16 to 80 centimeters times 16 centimeters times 6 centimeters. Okay, and don't forget the unit. The unit is centimeter cube because each of these have a power of 1 and down to cube. Okay. So let's do a multiplication. You want easy ways of doing this. Okay. So maybe I'll multiply 16 and 6 first. So this is my rough paper on this side. So 16 times 6, 6, 36, 6 remainder 3, 6, 1, 6, 9. Okay, so this part is 96, but we want to multiply by 20. But to multiply by 20, I can just multiply by 2 and add a 0 to the result. Okay, so this will be 6 times 2 is 12, and the 1, 9 times 2 is 18, plus 1 is 90. So it means that this product here is just 1920. Okay. Now, so this is the volume of the book. Okay. So we want to see how many of these can you fit in here. So we also have to find the volume of this and see how many of these will fit in. To find how many of these will fit in here, just you dividing the volume of this by the volume of that. Okay. So let's find the volume of the container. Volume means how much of the material can I take, okay, of the container. Okay. So what did we say it was? It was the length, 2,400 times the breadth, which is this, times the height, which is that. Okay. So let's do a multiplication. So this one is, we see there's a lot of zeros here. So let's put our zeros now. How many zeros do we have? We have 1, 2, 3, 4, 5, 6. So our answer will be in millions. Okay. Now we have to multiply 24 by 9 by 8. So 24 times 9. 9 times 4 is 36. Then 9 times 2 is 18 plus 3 is 21. Okay. That's 216. Then times 8. Okay. What's 8 times 6? 58. 48. Forgot to my times table. Okay. Then 8 times 1 is 8 plus 4 is 12. And 8 times 2 is 16. 16 plus 1 is 17. Okay, wow, that's a huge number, right? It's in billions, right? I hope my zeros are right. So 1728. Wow, that's a very huge number. Okay, and don't forget your units is centimeter. So volume means, the volume of this means this is how much of a substance it can take. Okay, but substance that we are looking at here is the book. Okay, so to find how many books it can take, we just have to divide how much the capacity of this is divided by this. Okay, so how many? So books fitting container. So we divide the volume of this. So it makes sense because your number of books doesn't have to have a unit, right? And you realize that when you divide this volume, the units cancel. Okay, that's a way of you checking the number. So let's write a big number here. So it's a billion, then 728 million. Wow, I have this money. If I win a jackpot and I win this money, we will expand this project. Okay, back. 1920. All right, my names, but we all see that it has. Okay, so let's do a simplification. So zeros, 1 0 cancels. Then, ooh, these numbers are yeah, really huge. So, but let's see. So we want to divide 1, 7, 2, 8. Let me leave the zeros for now. Okay, so now I have only 5 zeros remaining. Once divided by 192. Okay, let's see. How many times will this go here? So one way of doing it is you picking numbers and multiplying, okay? So if you multiply 192 by 10, you realize that it will be bigger than this, okay? Because what I'm saying is that 192 times 10 is 1920, okay? Which is bigger than this. But that means how many times this will go here is going to be less than 10, okay? Let's try 8. So let's try 192 times 8. This will be 16, 6 remainder 1. This will be, or maybe I should add a 0 to it. 7. Yeah, but we'll have, maybe we should add a 0 to this, yeah. Because from what I'm seeing here, it will still be the same because you get a decimal and yeah, no, it will still be the same. Okay. Let me try 8 first. If it doesn't work, then I'll try a smaller number. So what's 9 times 8? 72 plus 1, 73. So remainder 7. That will be 8 plus 7 is 15. Okay, so this goes here 7. Then we have 1, 5, 3, 6. Let's do a subtraction. This will be 2. We go 1, 12 minus 3, 9. 6 minus this is 1. Ah, we see? Yes, so we see that this goes here once. Have I made a mistake? Where? Yeah.
Let's check on the X2.
Come again.
Check on the X2, X9.
Yeah.
Yeah,
Oh, I should try 9. Oh, okay. Yeah, because 10 was a little big. Okay. Yeah. So I'm going to try 9. So 9 times 2 is 18. Remember 1, 81 plus 2, 82. Remember 8. This will be 9. 9 plus this is 17. Oh, okay. So it's just 9, okay? So it goes here 9, okay? So 1, 7, 2, 3. Okay. So we realized that the number of books that will fit here, so we had 9, but we had how many zeros here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So books, the number of books fitting in the container will be 900,000. So you see, the mathematics we do is very applicable. So this will apply in a book publishing company, right? When they produce books and they want to pack them into boxes, they know the volume of the books because they know the dimensions of the book. But with the math that we just did, we realized that in order for them to know how many books will fit into their boxes, they just need to find the volume of the box, the volume of the book, and divide the volume of the box by the volume of the book. So hope you enjoyed it. I'll switch now to Joel. So Joel will come and take over from you. So Joel did the introductory lesson on angles, which is on our channel. So go watch it. If you have any questions, send it to us via our social media pages. We'll be happy to help you with. Okay. You can also join us on our other social media pages to meet our other tutors. Okay. Okay. Hope you enjoyed it. Okay. Okay. Bye.
Okay, so we are going to the lesson for today, and we are going to take something on mapping for today. So, like I mentioned last week, we are taking only topics that we know that most times they will appear in your BECE questions. So that's basically what we are trying to do here. So today we are looking at mapping. Okay, so a little motivation. So when we talk about mapping, what we are basically looking at is finding a rule that we use in whatever that we are doing. So an example is that let's say there are these three guys who came to work for me on my field. So the first boy came, so this is boy, this is number of hours worked, and this is money paid. So the first boy worked for, let's say, 1 hour, and then I paid him 2 cedis. The second boy came, worked for, let's say, 2 hours, and I paid him 4 cedis. Again, the third boy came, worked for 3 hours, and then I paid him 6 Ghana cedis. Now the question is that, do I always have to take my time and calculate how much money I should give to somebody based on the number of hours the person has worked? And this is where mapping comes in. So mapping is going to tell me that, oh, based on these three things that I have done so far, I will get a general rule such that the moment the person comes, I only have to ask him, how many hours did you work for me? And then I will use that rule or that equation to get him how much money we are going to pay. So I'm sure you have already heard about mappings and some words that are associated with it. So we are going to hear words like maps to, are going to hear something like rule. Okay. So let's take it from here. So like the example I gave, I'm going to use the same thing as my first example for here. So here, the first thing is that this X that you always put there is representing something. So in this case, this is the number of hours the person worked for me. And then we are saying that we are mapping this thing to a certain Y value. So here you see the Y value also as the amount paid to him. So the amount paid. Okay, so what did we say was happening? We were saying that the first boy worked for 1 hour and I gave him 2 Ghana cedis. The second boy worked for 2 hours and was paid 4 Ghana cedis. The third boy worked for 3 hours and was paid 6 Ghana cedis. And we are saying this can go on and on and on. So the first thing that you are going to look at here is what we call the rule for this mapping. So the rule. The rule for the mapping. Because when we know the rule, then we can go ahead to find every other thing which is given to us. So in mapping, we looked at 3 different mappings that we can look at, especially at your level. So the rules that you are going to see could be linear, it could be quadratic, or let's say exponential. So these are the three rules that you may see. So your rule may be in a form like this. So when we say your rule is in a linear form, then it means that it's okay. So when we look at the linear, then we are saying that your linear is going to be in a form like y is equal to mx plus c, which is a line, the equation of a straight line that maybe you have seen already. When you look at the quadratic, just as the name suggests, then we are going to get something like y is equal to ax squared plus bx plus c. And then for the exponential, we are going to get something like y is equal to e power x. But for junior high school, hardly do you see something like this. So our concentration is going to be basically on the linear one because that is what you are mostly expected to get. Okay. So I'm continuing from here. So for the linear one, like I have already mentioned, you are going to get your rule to be stated like something in this form: y equals mx plus c. So here we call this y the predicted value, and then the m here is the common difference. And this common difference is also sometimes called the gradient. Now the x let me shift this thing forward a bit so you get the writing well. Okay. This is the input value. So this predicted value can also be seen as the output. So what you get at the end of the day. And then this is just a constant. Okay. So this is what should be guiding us even as you find the rule for the mapping. So we are going to input a certain value inside and then something is coming out. This is just like what we have been doing in primary school where they will tell you that you have a certain machine and then you put something in here and then a certain operation is done on it and then something comes out. So if you remember your primary days or kindergarten days, then that is what is happening here, exactly what is happening here. So we are going to use the example that I have given there so that we can find out the rule for this mapping. And then from there, we can move on to other things. So once again, let me go through what I said here. So we said the rule for the linear rule, we are going to get an expression in this form. We are going to have a y which is an output, and it's always given by the common difference, or what we call the gradient, multiplied by the input value plus some additional constant. This constant can range from any number at all. Could be negative, positive, zero, an integer, could be anything. Only that is going to be a constant. Okay. So let's look at how we are going to use this thing on the example we are dealing with now. So we said that there is some people working for me for some hours and I'm paying them some amount, and that's what we are looking at. So the first thing that we can use here is finding the gradient. So the gradient we say is m, and this gradient is always given by y2 minus y1 all over x2 minus x1. Okay. So coming back to this side, we can see that we have x, and all these are my x values. I can look at this one, and all these guys are my y values. So I can say this is my x1, this is x2, this is x3. Down here, I can say this is y1, y2, and then y3. So when you come to the gradient formula and it's telling you that the gradient is given by y2 minus y1, what it's basically telling you is that go to the y values that you see in what has been given to you already, and then you pick two values from the y, and then you subtract. Only that the first value that you put here should be greater than the second one. So it should be something at this side, because you have y1, y2, y3. So I can make this one my y2, this is my y1. Or I make this y2, this is y1, like that. And for every y value you choose its corresponding x value for your calculation. So in this case, I can say I am choosing 6 here as my y2. So then my m is going to be equal to 6 minus, then I choose a y1. The y1 could be this 4, could be these 2. You decide whichever one you want to. So let me choose this one. So 6 minus 2. And then I divide it by x2 minus x1. The moment I choose my y values, it means that my x values should correspond with them. I can't now choose any other thing but exactly what corresponded with these two guys. So I chose 6 here, so it means that when I come down, I should just move to this 3 and choose exactly that. So this becomes 3 minus, and then for the y values, I chose 2 here. So it means that I should choose this corresponding one, and that is exactly what I am going to do. So that's okay. Now, when we get to this side, this is a basic arithmetic, and then we can do. So we have 6, and we are taking out 2. That should give us 4. So we have 4 here, and then the denominator, we have 3 here, and I'm taking out 1, and that should give me 2. Then now this becomes 4 divided by 2. So I have 4 items, I'm dividing it among 2 people, and each person is supposed to get 2. Okay, so now from our formula we have up there, which is y being equal to mx plus c, we have dealt with one of the things in there, so our m is now gone. Okay, now what we are going to find is this c, because in the rule my y and x should be in there. They are going to be based on what I want to input, and then from the input I will get an output. So now our formula has now changed from y equal to mx plus c to y is equal to 2x plus c, because our m value has been able to be found and we said it's equal to 2. So now this is where we are. Now the question is, how do I get the value of this c? So to get the value of this c, you choose any two corresponding values from what you have already. So since we use these two guys, let's now go in for this guy. You can decide to choose the same people, but just for the fact that you want some people to also enjoy, let's do that. So here we are going to choose this as our input and this as its corresponding output. So this shows that this is going to give us 4 here, which is equal to these two counts, and then we want the x value. So we chose this 4 here, and for this 4, its corresponding x value is these 2 up here. So then this becomes 2 plus c. Okay. Then this gives us 4 minus 4 is equal to c. And we all know that 4 minus 4 is equal to 0. So this is equal to 0. So then that should tell me that to get how much I am supposed to pay somebody who works for me, the rule or the formula that I am going to use is going to be y, which is the amount I'll pay to the person, should be given by 2 times x, which is the number of hours the person works for me, number of hours, plus 0. And we know that 0 means nothing, so it's just that. So it means that for me to know how much I'll pay for anybody who works for me, my formula or my rule is telling me that I should just multiply 2 by the number of hours that the person is going to work for me. So yeah, now my question is, okay, so after now, how much will I pay a boy who works for 4 hours and 30 minutes? Okay. So we have a rule, and the rule is telling me that to get the amount I'm supposed to pay for the person who is working for me, I'm supposed to multiply 2 by the number of hours the person worked for me. Now somebody came to my field, person is working for 4 hours and 30 minutes. How much money am I supposed to pay to the person? So then we are looking for how much, and that is our y. And this should be equal to 2 times the input. The input is the number of hours the person is working for me. Here, the person is working for 4 hours and 30 minutes. And we know that 30 minutes is half of an hour. So then our input value is going to be 4.5 hours. And 4.5 hours can be seen as just 4.5. 4.5. Okay. So if 4.5, then here I have 4.5 being multiplied by 2. So 4.5 times 2. 2 times of 5 should give me 10. So that is 0, remainder 1. And then 2 of 4 should give me 8. And 8 plus 1 is 9. And then there is a 1 decimal place, so I put here. So this gives me 9. So it means that if somebody comes and works for 4 hours and 30 minutes, then that person is going to be paid 9 Ghana cedis. So this is our first example, and this is the general thing that we are supposed to know. Okay. Okay, so we are going to take some BECE past questions on mapping. Okay, so the first question I'm taking is from 2014 objective question 27. And this is what we have there. So we have X mapping to Y. We have 1 mapping to 3, 2 maps to 5, 3 maps to P, 4 maps to 9, 5 maps to 11, and then 6 maps to Q. Okay. Now the question is saying that find the values of P and Q. Okay. This question is very simple, and as an objective question, it is so easy to tell what the answer is going to be. Because another trick with mapping is that you can just observe what is happening. You can just observe what is happening. So from here, you can see that from 1 going to 2, there was an addition of 2. From 4 going to 5, there was also an addition of 2. So that should give you a clue that what is happening here is just plus 2, plus 2, plus 2, plus 2. So as an objective test, this one from here to here, from there to there, from here to here, there to there, and then you check whether it's true. So you can see that from 3 to 5 is plus 2. So this is plus 2. This to this, you should also have a plus 2. This should give you another plus 2, plus 2. So if it is plus 2, plus 2, plus 2, which is happening, then we should know that from here to here, the value of P is then going to give you 7. And when you are at 9, you go to 11. Then from 11, you are going to Q. And we are saying that the rule is plus 2. Then when you add 2 to 11, you should get 13. So your Q should be equal to 13. But what if this were to be a theory question? Then you must go through the process that you went through. I first of all told you that in your level, you are going to get some mapping questions which are going to be from either linear or quadratic. Now the question is, how do you determine whether this is a linear problem or a quadratic problem? So this is what you do. So let me first fix because we know this and we know that. So we are saying that this one is going to be 7 and this side is going to be 13. So this is what you do. You check the common difference of the y values. You check the common difference of the y values. So if you go one step and you recognize a common difference, then what you have is linear. But if you go 2 steps before you find a common difference, then it means that what you are dealing with is quadratic. So you look for the difference between these values. So if you just do it once and then you see that when we take this from that is the same value as from here to there, then we say it's linear. But if you do the, okay, I'll take an example on that one so that you know what I'm talking about. So for this one, which we are saying is linear, and I'm finding the common difference of my y values. So 5 minus 3 is giving me 2. Now 7 minus 5 is also giving me 2. 9 minus 7 is also giving me 2. 11 minus 9 gives me 2. And then 13 minus 11 is giving me 2. So here you can see that there is a common difference in between all of them. Now let's take this example and see. So let's say I have x mapping to y, and then I have 1 mapping to, let's say, 1. 2 maps to 4. 3 maps to 9. 4 maps to 16. On and on it goes. Now let's see what happens here. Here, 4 minus 1 gives me 3. 9 minus 4 gives me 5. 16 minus 9 gives me 7. So you can see that between these ones, the difference are not the same. So we have gone the first step, we did not get a common difference. Then we check the common difference between this difference also. So here 5 minus 3 gives me 2, and then 7 minus 5 also gives me 2. Then it means that this mapping is a quadratic one, and then this one is a linear one. Then since you know the formulas for the rules, you use those rules to determine what to be done. Okay. Now let's take another example where you have a value for the C. I will leave this slide so that if somebody wants to copy something. This is basically what we have done. So let me just adjust this more. So this goes to 4, 6, 8, 10, and then let's see, 12. Let's see. Okay. what I had there. So this is supposed to give me 4. And we have 6 here, and then have here as 14. Okay. So let's assume this is it. So I have an x and its values are this. I have a y and we have these values. So the first thing you must look for is to determine whether it is linear or quadratic. You must first determine whether this is linear or quadratic. So I told you to test for that, you check for the common difference. So you check for this one, you have a common difference of 2. This, you have a difference of 2 here, 2, this and this, a difference of 2, this and this, a difference of 2. So this tells us that what we are dealing with is a linear problem. So if it's a linear problem, then the question is, what is the rule? What is the rule of this mapping? Okay. So, like I mentioned earlier, the moment you know that what you are dealing with is a linear problem, then you know that you are looking for a certain equation of this form: y equals mx plus c. Another quick way of finding this value of m is the common difference. So we say that common difference that you will get from there is the gradient, and it is given by, we said the m is equal to y2 minus y1 all over x2 minus x1. And then you choose values to put there. So assuming I choose my y2 to be 10 minus y1 6, and I divide it by their corresponding x values. So 10 for the y corresponds with 4 in x. So here will be 4 minus 6 in the y corresponds with 2 there. So that gives me 2. This should be equal to 6 from 10 should give me 4. And then 2 from 4 should give me 2. And this is equal to 2. And you can see that this value 2 is the same as the common difference which was between all of them. So I am saying that if you want to be fast with your calculations and it's not maybe a theory question where you must show all these workings, then the fastest way to get the value of the m is to check for the common difference, and that should basically fit for the value of m. Okay. So now that you know that our m is equal to 2, then we must find the value of c. We must find the value of c. Okay, so here we have y to be equal to 2x plus c. And then I'm saying that at this point, what you must do is to pick one x value and its corresponding y value, and then you test to get your value of c. So here, I'll just choose this first values here. So from those values, our y is equal to 6, and this 6 should be equal to 2 into the x value is 2 plus c. Okay. So then this gives us 6, which is equal to 4 plus c. Then the value of c should be 6 minus 4, which is equal to this. And then that value c is equal to 2. Then it means that in this mapping, we are going to get the rule to be y to be equal to 2x plus 2. So if this is the rule for the mapping, then what will be the output? of 1. So the one that I robbed, if I am to bring it back, what do you think will be the value of that 1 in place of the y? So all that you have to do is simply take this 1 and then bring it here. So that should give us 2 into 1 plus 2. And then 2 times 1 is 2 plus 2 is 4. So this value here is going to be 4. And then that thing is filled. As simple as that. Okay. Let me try and get another BECE question on that. This slide. Let me put this word problem there so that you see how we can tackle it. So first is the number of boys in the group, and then this is the days they use. Okay. So if you have 3 boys, then they are going to use, let's say, let me try and get something. Let's say we have 5 here. And if they are 4, let's say this gives us 8. We have 5. We are getting 11. Gives us 14. And then 7 boys are using 17 days. Okay. So I am bringing this example to show you that it's not every time that we are going to have X and Y and something like that. Like we are saying that math is very practical. You can get something like this. So this is the number of boys in a group, and then this is the number of days that they use to work. The number of days that they use to work. Okay. So we have this. This may not sound good in practice because you don't expect that if I have a field, then 3 boys should use less days than 7 boys. But this is just to demonstrate that you can get something of that sort. So here, this is simply the same as what we have as X. So here you have the number of boys as your X, and then you have the days as your Y. We can also get the other way around. So let me say that I can as well change this so that I have here days. So your days is your X, and then this is the number of boys. And that should be your Y. Okay. So for 3 days, you have 5 boys. For 4 days, you have 8 boys, something like that. So these are just variables. It can change at any point in time. So now we are saying we want to find the rule which is being used here. So this may tell you that as you add more people to the field, the attitude towards what they are doing now comes down, so they use more time than if they were supposed to be less. So if we have our X here and then we have our Y here, then the mapping will just be X into 5, 4 maps to 8, 5 into 11, 6 go into 14, and then 7 here to 17. Okay. So once again, you can't just go straight to say that it is this or that unless you check for the common difference before you can determine whether it's either linear, quadratic, or exponential. So here, let's check for the common difference. 8 and 5 gives us a common difference of 3. 11 and 8 gives a difference of 3. 14 and 11, difference of 3, 17, 14, a difference of 3. So this should tell you that we are dealing with a linear problem. So if it's a linear problem, just like I have mentioned already, the M can simply be this common difference. Then the rule is now going to be Y being equal to 3x plus C. So to get this C, we are going to just choose any of these guys to do the thing. The reason why I prefer choosing the first one is that always the first one have the smaller numbers, and in mathematics it's always necessary or easier to use small numbers to get what you are looking for than the big numbers. So here I have my 5 here, and that is giving me 3 into the x value is 3 plus C. Okay. So now let's see what is happening here. This side we have 5 here, which is equal to 9 plus C. So then here you're going to have 5 minus 9 is equal to C. So that should tell us that our C here is going to give us a negative 4. So if that is the case, then what it means is that the rule for this mapping is now going to be Y being equal to 3 times X, so 3X minus 4. 3X minus 4. So we have 3X, 3 times 3 is going to give us 9, minus 4 gives us 5. When you pick this one, 4 times 3 is 12, and 12 minus 4 is 8. So this is the relationship that is happening between these two groups. Okay. These things you are seeing are exactly what happens in linear graphs. In linear graphs, this is exactly what is happening there. So, like I said, this common difference is the gradient. So I'm going to try and get an example where our gradient is going to be negative, or the common difference is going to be negative. And then from there, we can take some quadratic examples too. So here we are having 1 giving us, let's say, 13. We have 2 giving us 10. We have 3 giving us 7. We have 4 giving us 4. We have 5 giving us 5 gives us 1, and then on it goes. So now let's find the gradient or the common difference. So here it's always what is at the right hand side minus the left hand side. So here we are having 10 minus 13, and that should give us minus 3. 7 minus 10 should give us another minus 3. 4 minus 7 should give us minus 3. And finally, 1 minus 4 should also give us a minus 3. So then we know that this one, we are going to get a gradient which is minus. The same way, if we are to go by what the actual m value is supposed to be, we have m here to be equal to y2 minus y1 all over x2 minus x1. And like I said, you can choose any of the y values and their corresponding x values. So this should give me, assuming I want to take these values here. And then let's say here. Then I am going to have my y2 to be 4 minus y1 here 10. And I should divide this by the corresponding x values. So the corresponding for y is this one, 4. Minus for the 10, I have this 2, which is here. So 4 minus 10 should give me a negative 6. And then 4 minus 2 should give me positive 2. But you know that when you divide a negative number by a positive number, the result is still going to be negative. So this gives me the negative 3. So exactly what we are getting here. Okay. Then now we move on. So this gives us y being equal to minus 3x plus c. So we are still going to search for our c. So we choose any of the numbers. So here, this is 1 and 13, and we have 5 and 1. Which one will you go in for? Now, definitely go in for this one, because I don't know what the 13 is going to do. Maybe it could be something easy, but let me just choose this one. So in this case, I have my y value rather be 1, because that is what I have here. And this should be equal to minus 3 into the x value for this side is this 5 plus c. Okay. So when I multiply that, this should give me minus 15 plus that. And then I want my C. So then my C becomes this one, this move to the other side. So plus 15, and this should give me 16. Okay, so it means that the rule for this map in here is giving us y being equal to minus 3x plus 16. Okay, I hope that's is fine. Okay. In that case, what do you think will be the value of 10 in this mapping? Try and do it, and then maybe you put the answer in the comment box for me using this rule for this mapping. What do you think will be the value, the output, if I have here 10? What do you think will be the output of this value for the 10? What do you think will be? Okay. So we are taking the next one, and then we see what it will be. So now in this mapping, we are saying that we have amount, and then we have the retains. Okay, so we are saying that a certain company decided to invest some amount of money into a business that they are doing, and then the corresponding returns is what we are going to see. So we have the amount that they will invest, and then the returns that they get out of it. Then we will tell what is happening there. So let's see. This is the deal. So let's assume that these amounts that I'm talking about are in millions. So if they invest 1 million Ghana cedis, the returns they get on it is 2 million. When they invest 2 million, the returns they get on it is 5 million. When they invest 3 million, the returns they get is 10 million. When they invest 4 million, the returns is 17 million. And then finally, when they invest 5, the returns they get is 26 million. So now we want to see what kind of rule is happening with whatever they are doing. We are going to look at what is happening behind the scenes so that they are getting all these returns. So, like I'm saying, there's an investment company. These investment companies, what they do is that they gather money, they take monies of their clients, and then when something happens to their clients, they pay something to them. But they don't want to keep the monies at their side, so they also invest into something else, and then the return that they get on it, that is what they use to pay their clients in case of anything. So they gather 1 million, they put into a certain investment, and then the returns they get out of it is 2. They go in for 2 million, they get 5 million as a returns. they put in 3 million, they are getting 10 million as a returns. So what is happening at the other side? And are these people making profits or they are making loss? Are they gaining, losing? All these things can go into it. But for the sake of this, we are looking for just the rule for this mapping. Okay, so like I said, here you can take the amount as your X, or that is how much they invest. This is how much they input, how much they put in to the investment, and the returns is what comes out of it. So now we have this as our Y value. Okay, so the first thing we are supposed to do is to determine whether what is happening behind the scenes, is it a linear kind of thing? Is it quadratic? Is the money moving exponentially or whatever? So that is the first thing we are supposed to check. So I say to check for that, you deal with the Y values. So let's see. So with the Y values, we have 2, 5, 10, 17, and then 26. Now let's check the difference. 5 minus 2 is giving us 3. 10 minus 5 is giving us 5. So the moment you reach here, something should tell you that no, what I'm dealing with is not linear, because if it's linear, then I'm expecting to see a common difference. The thing should be common with all of them. But this, after just the 2, it's not. Let's move to the other one. Maybe this and this will give us something closer to this. Let's see. This and this, 17 and 10 is giving us 7. It has changed again. And then finally, 26, 17 is giving us 9. So it means that automatically, whatever is happening behind the scenes of this is not anything linear. So we go a second step and then check for difference between these first steps and see what is happening. So here we have 5 and 3 is giving us 2. This and that is giving us a common difference of yet again 2. This and this is also giving us 2. Okay. So the moment you see this, we went 2. This is the first difference we found, and this is the second difference we found. So it was after this that we saw that we are getting something which is common. So it means that whatever we are dealing with is quadratic. And then I told you that in the quadratic case, we are going to get the thing to be y being equal to ax squared plus bx plus c. So here, this common difference that we have had, we are going to see how it's going to help us to get whatever we have there. So here, what we do is that we just choose any of these values and then see what is happening. So the trick is that you have seen that this thing is quadratic, and then it's telling you that if it is quadratic, then you are going to take the input values and then square them. So the first thing we look out is to see what if the rule was just y is equal to ax. What if the rule was just y is equal to ax? What would have happened? So now let's choose this and then see what happens. So here we are having 2 here to be equal to ax squared, and our a is 1, so 1 squared. So if it is 1, then this side we are going to get, no, let me do it this way. So let's assume we are just dealing with the x values. Let's assume we are just dealing with the x values. Then when I take this one, we have 2 giving us 1 squared. So 1 squared definitely plus something. When we take the next one, this is 5. Here we had 2. So when I square a 2 plus something should give me this 5. Then I take the next one. That was here 10. And it's saying that when I square the 3 plus something, I should get my 10. So now we can see that this thing is now changing from whatever we know to the linear one. We said it's a quadratic. So after we know this way, then we are going to get the other one, which will be the value of the c. So here, 1 squared is 1 plus c. And we are saying this value should give us 2. When we come to this side, we are saying that 2 squared is 4. So we are saying 4 plus c should also give us the y value, which is 5. And then when we come to this one, we have a 9 plus c, which should also give us 10. So now the question is, which values are we going to add to this, which is this c? Because the c should be a constant, it should be the same value. So what same value can we add to 1 so that we get 2? That same value, when we add to 4, we get 5. That same value, when we add to 9, we are going to get 10. So from here, you can just choose any of these equations and then solve. So assuming I take this first one, then we are going to say that the c is going to be equal to 2 minus 1, and this should give us 1. So then the rule for this mapping is now going to give us returns, which is equal to the amount squared plus 1. The amount squared plus 1. In simple terms, all you are writing is y is equal to s squared plus 1. So this is the rule for that mapping. And this one, for BECE, they are not going to bring you the full thing so that you get suffered, but just something that you can just observe and then see what is happening. So like I said, the quadratic, the general form is y being equal to as squared plus bx plus c. So comparing this one to this one, what it means is that the a from here, the a is equal to 1, the b is equal to 0, and then the c is equal to 1. So that when I place 1 here, 1 times s squared is giving me s squared. When I place the 0 here, 0 multiplied by any number should give me 0. That is why we don't have the second component in here. And then the last part is c, which is equal to 1. And that is it. Okay. Okay, so that will be all for today. That's where we want to end for today. So if you have any more questions, you can drop it in the comment box so that we look at it next time. But in the meantime, from now till next Sunday when we meet and bring you yet another topic, you can just go through some more BECE questions on mapping. And then if there is any issue, you can just drop it in the comments or you send it to me via email. So the email is simply joel at ames.edu.gh. So Joel at aims, aims.edu.gh. So that is it. And that will be all for today. Goodbye.